Hello and welcome to EC Electronics. This is a part 2 of electronic instrumentation and measurements question and answer. This is also a very highly requested video. Okay, so we are going to see some more questions. I have tried to include a maximum variety of questions in this video. So let us see what are the questions. So the first question is, resistances R1 and R2 have nominal values of 10 ohm and 5 ohm. So the values are actually 10 ohm and 5 ohm. And the limiting errors plus 5% and plus or minus 10%. The error should be, the limiting error should be in plus or minus form. So plus or minus 5% and plus or minus 10%. The output resistance and limiting error of series combination are dash. So in the part 1 also we have discussed I think 2 or more questions like this. So why I am including this question, or why I am starting off with such a question, because I was receiving a lot of doubts on that question, that how the resistance is varying like this, how the error is being added to the resistance, how the error we have to detect or add. So likewise a lot of confusions were there. So let us try to clarify those confusions here first. See here 10 ohm is having limiting error of plus or minus 5% means 10 into, I'll write it here, 10 into 5 by 100. How much it is? It is 0.5, right? 0.5. This 0.5 ohm is actually the error value. So if the original value is 10, means the resistance can be either 10 plus 0.5 ohm or 10 minus 0.5 ohm. Okay, since this much of error is included, this much is a limiting error means, so first you have to calculate out of the given percentage, how much is it in the resistance value. It is just a error percentage given, right? We have to calculate what is the value of resistance coming under this percentage. So it is 10 into 5 by 100. Okay, that is taking 5% of 10. Symbol. So you will get 0.5 ohm. 0.5 ohm is the error, resistance error. So it can be, so if you are connecting in this resistance in some combination, in any combination, the resistance value can be 10 plus 0.5 or 10 minus 0.5. Or you can write the new value of resistance will be 10 plus or minus 0.5 ohm. I hope the concept is crystal clear. Next, see, so the error value is 10 plus or minus 5 ohm will be the resistance value actually. It can go up to 10.5 or it can go below 9.5. Okay, or up to 9.5 it can go. Next, for 5%, the error, the limiting error is, for 5 ohm, the limiting error is 10%. So it is 5 into 10 by 100, right? It is again 0.5 ohms. So now you can actually change, or you can actually write the resistance values, that is 10 ohm and 5 ohm. We can write, by including the errors, it will be 10 plus or minus 0.5 ohm and 5 plus or minus 0.5 ohm. These are actually the values of resistors including the error. Okay, now see, the question is, we are going to connect these resistors in series connection. Okay, so when the resistors are connected in series connection, the error will be also getting added. Okay, so how will the resistance will change? It is 10 plus or minus 0.5, then 5 plus or minus 0.5 will be 10 plus 5, it is 15, then 0.5 and 0.5 error, that is error resistance. That is the error value included with the resistance. So it will be also getting added. So it is 15 plus or minus 0.5 plus 0.5. 0.5 plus 0.5 is 1. So it is 15 plus or minus 1 ohm will be the resistance including the limiting error of the series combination. I hope it is clear. See, 10 plus 5. Then the errors, it is 0.5 ohm and 0.5 ohm. Add those because it is a series connection. So 0.5 plus 0.5 is 1. That is 15 plus or minus 1 ohm is the output resistance of the series combination. Now they are also asking the limiting error. The limiting error is actually expressed in percentage. Okay. So here the resistance, output resistance is how much? I'm going to write it here. 15 plus or minus 1 ohm. Okay. That is output resistance. Now out of this 15 plus or minus 1 ohm, this 1 ohm is the resistance contributed by the error percentage, right? So how much is this 1 ohm? That is how much is the limiting error percentage for this 1 ohm resistance? How it will be calculated? That is, we need to find the limiting error for 1 ohm. It is 1 by 15 into 100. Right? That is, we have to calculate how much percentage is 1 out of 15. It is 6.67 percentage. So in the series combination of these two resistors, there is a error percentage of 6.67. That is a limiting error. There is 6.67 percentage in the series combination. Okay. So how we are calculating this? First, you have to find the resistance contributed by this limiting errors. So for 10 ohm, it is 10 into 5 by 100. For 5 ohm, it is 5 into 10 by 100. The errors, the resistance contributed by the errors will be 0.5 ohm and 0.5 ohm for both the resistors. And since the resistors are going to be connected in series connection, total resistance or total output resistance is 10 plus 5, 15 plus or minus 0.5 plus 0.5, that are two error or the two resistance contributed by the error. So it will be 15 plus or minus 1 ohm is the output resistance. Now in the output resistance, there is a total resistance of 15 and 1 ohm contributed by the error. Now how much percentage is this 1 ohm out of 15? That much is the limiting error. Okay. So 1 by 15 into 100. The percentage is 6.67 percentage. I hope it is clear. So correct answer will be 15 plus or minus 1 percentage is the output resistance. Limiting error is 6.67 for the series combination. Correct answer is option A. Let us move on to the next question. Okay. So this is one type of question that can come from the error and tolerance session. Next question. A 0 to 300 volt voltmeter has an error of 2% of the full scale deflection. If the true voltage is 30 volt, then the range of reading on this voltmeter would be how much? Okay, so the true voltage is 30 volt. True voltage is 30 volt. And this 0 to 300 volt voltmeter, this is actually the range of the voltmeter. The voltmeter value starts from 0 up to 300 is the maximum full scale value. Okay, here the true voltage is 30 volt. And also it is been given that the error percentage is 2%. Okay, so if you are getting if you are going to read a 30 volt, you have to also include this much of error voltage contributed by this 2%, right? So how much is the 2% of 30? 30 into 2 by 100. It is 3 into 2, 6 by 10, which is 0.6 volt. Okay, so if you are going to read at 30 volt or any voltage, say it is X volt. This is the true voltage. You have to add or subtract this much of error voltage also. So you have to calculate the 2% of this true voltage, that is X into 2 by 100. And you will get some voltage here. Here for this question we have obtained it as 0.6 volt. That means the voltage can range from 30 plus 0.6 maximum to minimum 30 minus 0.6 is the scale of output range can go. That is, the output can either increase to this much, including this 0.6 error, or the output can decrease to this much. Okay, so it can be 30.6 or it can be 29.4 volt. So this is the range. Okay, the options given here are 20 volt, 40 volt, no. 24, 36, no. 29.4, 30.6 is the correct answer. Correct answer is option C, which is 29.4. So it is written in the reverse. 29.4 is the minimum. 30.6 can be the maximum, including the error. Okay, so this is the range. Correct answer is option C. The next set of questions is this. In a dual slope integrating type of voltmeter, the first integration is carried out for 10 periods of supply frequency 50 Hz. If reference voltage is 2 volt, the total conversion time for an input of 1 volt is dash. Okay, so the basic equation for a dual slope integrating type of voltmeter, if you have at least heard about this or if you have studied the basics, it is T1 by T2 into V in is equal to V reference, where T1 is the time period for first integration or the time to which the first integration is done. T2 is the time to which the second integration is done, and conversion time is equal to T1 plus T2. Okay, so conversion time is T1 plus T2. Here we have been given V in and V reference directly. We don't know what is T1 and T2. Okay. First, let us study that or try to figure out that. Okay, so it is said in the question that the first integration is carried out for 10 periods of 50 Hz. Okay, so if it is a 50 Hz, it is a frequency. What is the time period? It is 1 by 50. So 1 by 50 is the time period, and for 10 periods of this time period means 10 into 1 by 50 is the first integration time duration. So T1 is equal to 10 into 1 by 50. I hope it is clear. So it will be 1 by 5 or 0.2 seconds is the first integration time. Okay. So T1 we have obtained as 0.2 seconds. So you can write the equation again. T1 by T2 into V in is equal to V reference. So we have obtained T1 as 0.2 seconds. Then T2 we will keep it as it is. V in is 1 volt is equal to V reference is 2 volt. Okay. So we'll get T2 is equal to 0.2 by 2. So it will be 0.1 seconds. T2 is 0.1 seconds. Now we need to find the total conversion time. It is T1 plus T2. That is 0.2 plus 0.1 is equal to 0.3 seconds is a total conversion time. Correct answer is option A is the correct answer, which is 0.3 seconds. Now while solving this question, the most important equation you need to note down is this. Okay, shall I remove this? T1 by T2 into V in is equal to V reference. Please note this equation down. This is a basic equation for a dual slope integrating type of voltmeter. Okay, so you'll be if you Google it, you have to Google as dual slope integrating type of digital voltmeter DVM. Okay, the equation is T1 by T2 into V in is equal to V reference. Moving on to the next question. The limiting errors of measurement of power consumed by and the voltage error resistance are plus or minus 5% and plus or minus 15%. That is, the errors of power and voltage is being given as plus or minus 5 and plus or minus 1.5%. The limiting error of measurement of resistance is dash. So here we have been given the power P, voltage V, all errors are being given. We need to find the error while calculating the resistance. What is the relationship between these three? P is equal to V square by R. Here we are going to measure resistance. So it is R is equal to V square by P. So we have been given the error for voltage. We have been given the error for power. So it is V square by P, right? So what is the error for power? It is plus or minus 5%. So it is, since it is power, it is plus or minus 5%. Next, what is the error for voltage? It is plus or minus 1.5%. Okay, since it is V square, while calculating the error, please listen now. How to calculate the error percentage? It is V square by P, right? So what is error for V? It is 1.5. So you have to write 2 into 1.5 then by error of P. So plus all errors we have to add. Okay. We are not dividing or anything for errors. We have to add all errors. Because while taking measurements or while calculating, these errors will not get eliminated. It will get accumulated always. So we have to always add the errors. Now what is the error for power? It is 5. So 2 into 1.5 is 3 plus error for power is 5. So it is 3 plus 5 is 8. So the error for calculating resistance is plus or minus 8%. It can be plus, the error can be added, or the error will be deducted from the measurement. It can be either ways, or added or subtracted. So this is how you have to calculate the error while, that is a limiting error while calculating the resistance. V square by R. So it is 2 into error for V plus error for power P. So 2 into 1.5 plus 5, it is 8 plus or minus 8%. Correct answer is option C is the correct answer, which is plus or minus 8%. Question is this. It is regarding or connected to the 3-phase system, that is 2-watt meter method for 3-phase measurement. This method is called 2-watt meter method. So if you want to know more about it, please Google the term 2-watt meter method. So here in the 2-watt meter method, we are going to connect 2-watt meters to any system where we want to measure the power. Okay. So the watt meters are used for measuring power, and here this is a 3-phase system. These are the 3 wires, and 2 watt meters are being connecting these 3 wires. Okay. So the question is 2 watt meters connected to measure the total power on 3-phase system. So the aim is to measure the total power. Supplying balance load, and they reads 10.5 kilowatt and minus 2.5 kilowatt. So these are the 2 readings of these 2 watt meters. Say W1 is equal to 10.5 kilowatt and W2 is equal to minus 2.5 kilowatt. Okay. The question is, the power factor is dash. We need to find the power factor. So before going into the power factor and anything, so if W1 is 10.5 and W2 is minus 2.5, what is the total power calculated? The question can also be like that, right? So if the first reading or the reading of the first wattmeter is 10.5 and the second wattmeter is minus 2.5, then total power, please note this equation, total power is equal to W1 plus W2, which is 10.5 plus 2.5, which is equal to 10 plus 2 is 12. 0.5 plus 0.5 is 1. So 13 kilowatt is the total power. Total power is 13 kilowatt. Always you have to add the readings of the 2 watt meters to get the total power. Okay. Now the question is not that. The question is to find the power factor. Now, how to calculate the power factor? For that, we have to introduce another term. So, I'm going to remove this figure. I hope that you have noted this. See, for finding the power factor, the relationship is that tan phi is equal to root 3 into P1 minus P2 by, okay, in terms of WL, right? W1 minus W2 by W1 plus W2. Okay, where W1 is the reading of the first wattmeter, W2 is the reading of the second wattmeter, and is equal into root 3 is equal to tan phi. If this is the relation, then the power factor is defined as cos phi. So from this relation, we have to calculate phi. Then we have to take the cosine of it. Then you will get the power factor. Okay. So you have, you know all these terms, W1 and W2 you know. Then you can calculate tan phi, take the tan inverse and substitute in the cos phi term. Okay. So you are going to calculate tan phi is equal to root 3 into W1 minus W2 is 10.5. Okay, I'm sorry. Okay, so there is so we have discussed that the total power, how to calculate the total power. Okay, so earlier we have taken the total power as W1 plus W2. It is not 13. W1 plus W2 is actually 10.5 minus, sorry, I'm really sorry. 10.5 minus 2.5 is 8 watt, 8 kilowatt. Okay, so the total power is not 13. Please correct it. It is 8 kilowatt. Only the confusion was in the calculation because I ignored this negative sign. There is a negative sign for the second power. So it is 10.5 plus minus 2.5. So it is not 13. It is 8 kilowatts. I hope it is clear. I hope you have corrected. Okay. Next we are going to calculate the power factor. Okay. Again, we are going to take tan phi is equal to root 3 into W1 minus W2 is, I'll write the general expression once again, W1 minus W2 by W1 plus W2. This is the correct expression. Okay. So, root 3 into W1 minus W2 it is 13. So, 10.5 minus 2.5 is plus 2.5 by 10.5 plus, so it is minus 2.5. Okay, the second power was negative. I have not taken that in earlier calculation. So it is root 3 into 13 by 8. Okay, so if you solve it, you will get tan phi is equal to 2.81 will be your tan phi. And you have to take phi tan inverse of this. So for calculating the power factor is equal to cos phi. That is equal to cos of tan inverse of 2.81. Okay. So you have to take phi. It is tan inverse of 2.81. If you take tan inverse of 2.81, you will get phi. And cos phi is the power factor. And you will get the value as 0.334 is the correct answer, which is option A is the correct answer. Cos phi is the power factor. So please note down, power factor is equal to cos phi, where we are taking phi from the relation tan phi is equal to root 3 W1 minus W2 by W1 plus W2, where W1 and W2 are the powers of the that is reading of the 2 watt meters. Okay, correct answer here is option A is the correct answer. Question is from the Maxwell's bridge. So Maxwell's bridge will be having this setup, and it is used for measuring of unknown inductance generally. So this Maxwell's bridge is actually an advanced version or a change in version of Wheaton's bridge, where we are going to measure the value of unknown resistance. This Maxwell's bridge we use for measuring the value of unknown inductance or inductor. Okay, so here it consists of inductors and capacitors. Okay, generally we use it for measuring of inductance. Okay, so here the question is, in the Maxwell's bridge as shown below, the values of R1 and L1, that is R1 is the resistance, L1 is the inductance of the coil, are to be balanced. After balancing, the values are dash. There are various options given. So how to calculate this unknown values of resistance and inductance? So in order to find that, we have to apply the balance equation for the Maxwell's bridge, and it is given by Z1, Z4 is equal to Z2, Z3. So Z1 and Z4 is the impedance of, Z1 is the impedance of this branch, Z4 is the impedance of this branch, Z1, Z2 here, sorry, it is Z4 here, Z2 is here, Z3 is here. Okay, now we have to equate Z1, Z4 is equal to Z2, Z3, this equation. Okay. Now, what is Z1? Z1 is combining of resistance and inductance. So, it is R1 plus J into omega into L1. Okay, so this is a little bit difficult question. Please listen carefully. Okay. R1 plus J omega L1 into here, this is Z4. So, it consists of this resistance 4000. I'm going to call it as R4. And this I'm going to call it as C4. In order to write, that is for the simplicity of the equation. So, they are connected in which connection? Parallel connection. So, you have to apply the parallel rule there, combining the capacitor and the resistor. So, it is R4 into 1 by J omega C4 by R4 plus 1 by J omega C4. Now, here you can do a simplification. That is, if you proceed further, it is more complicated. So, we can do a simplification here. There is this J omega C4, there is in the numerator, and in the denominator, if you take a common, that is, you can write this as R4 into J omega C4 plus 1 by J omega C4. Right. So, you can cancel this J omega C4 in the denominator with the 1 by J omega in the numerator. So, it is more simplified and looks neat. So, it is R4 by R4 J omega C4 plus 1 into plus 1. Yeah. So, this is Z1 into Z4 is equal to Z2 into Z3. Z2 is R2. Simply there is a resistor and another resistor in R3. So, it is R2 into R3. Very simple, right? So, now we have obtained this equation. Next, I am going to take R4 and multiply to inside of this bracket, and I am going to take this in the denominator. I am going to multiply it with R2, R3. Okay. And I am going to simplify and write the equation. So, it is R1 plus J omega L1 into R4 is equal to R2, R3 into 1 plus R4 J omega C4. Right. I'm going to remove this equation, just cross multiply, nothing else. Okay, so in this video I have included not very simple question, try to include a little bit higher end question. Okay, so this is the equation we are getting. Now I'm going to multiply all the terms to inside the brackets and I'm going to expand it. So I'm going to get R1 R4 plus J omega L1 into R4 is equal to, in this side of the equation it is R2 R3 plus I'll remove this little bit. Okay, plus J omega C4 into R4 is there, R2 is there, R3 is there. Okay. Alright. Now, if you see this, both sides of the equation, there is a voltage source. I've just removed it. Okay. Okay. So, if you see this side of the equation and this side of the equation, you can see this is a complex number consisting of a real part and an imaginary part. And also, this is a complex number in this part of the equation with a real part and the imaginary part. And they are equal. So, how will it be? We have to equate the real parts and we can equate the imaginary parts. Right? Very simple. So, I'm going to equate the real parts first, which is R1, R4 is equal to R2, R3. Right? So, what is the value of R1 that we need to find? R4 is 4000. So, R1 into 4000 is equal to R2 is 2000 into R3 is 750. So, I'm going to cut off this 2000 by this 4000 and you will get a 2 here. So, R1 is 750 by 2. What is 750 by 2? It is 375 ohms is the value of R1. R1 is 375 ohms. I hope you understood how to find R1. Okay. So, this is Maxwell's bridge balancing problem. Okay. So, you have obtained R1 is 375 ohm. Okay. If you have these options you don't need to proceed further because only one option is having 375 ohm, which is option A. Anyway, we can calculate L1 also, right? For that, I'm going to equate the imaginary parts now. So I'm not going to take j omega because it is common in both places, and also this is common. R4 is common for both this imaginary part and this imaginary part. So I'm going to take the remaining. So it is L1 is equal to it is a C4 into R2 into R3. What is C4? It is 0.5 microfarad. So 0.5 into 10 raised to minus 6 into R2 is 2000 into R3 is 750. Okay. So if you solve it, you will get 75 millihenry. Okay. L1 will be obtained as 75 millihenry. Okay, so the correct answer here is option A is the correct answer. So this is another type of question. You can expect it. Electronic instrumentation and measurements session or subject. This is called the Maxwell's bridge balancing problem. And you have to use the equation Z1, Z4 is equal to Z2, Z3. Correct answer here is option A. The average reading digital multimeter reads 10 volt when fed with a triangular wave symmetric to time axis. If input is same, the RMS reading meter will read dash. So one is average reading meter and another one is RMS reading meter. So average reading meter when fed with a triangular wave is giving an output of 10 volt. So average for a triangular wave is Vm by 3 and it is obtained as 10 volt for an average reading meter. So Vm is equal to 10 into 3 which is equal to 30 volt. Okay, now if this same voltage or the same wave is fed to a RMS reading meter, then we need to find Vrms, right? Vrms is equal to Vm by root 3, right? Vm is, we have obtained as 30 by root 3 or 3 into 10 by root 3 which is 10 root 3. 10 root 3 is the output or the reading of the RMS reading meter. Correct answer is option D is the correct answer here. This is a theory question. I'm not going to write the question. I'm just reading it. So the question is based on the CRO. Okay. To the Y input of a CRO, we are going to feed a signal of 10 sine 100t. This is fed to the X axis. Sorry, this is fed to the this is fed to the Y input. Okay. And to the X input, we are feeding 10 cos 100t to the X. Okay. The gain of both X channel and Y channel is same. The output screen will show dash. So we are going to feed a sine wave and of amplitude this much and a cos wave of this value. The sine wave is fed to Y and cos wave is fed to X channel. The gain of X channel and Y channel is same. So what is the output shown on the screen? In a CRO, the question is this. Okay, so the output obtaining here is called the Lysage's pattern. The Lysage's pattern is obtained. Okay, so if in the question or in the option it is being given a triangular wave or B a circular wave or a square wave like that, you have to choose which wave it is, a circular wave or a circular pattern. Okay, so if the options is a sinusoidal signal, B a straight line, C an ellipse or D a circle, you have to choose a circle. So it is actually called a Lysage's pattern. Okay, so the Lysage's pattern is obtained if X and Y is fed with a sine and a cos wave with both channels having same gain. And also another question is that what is the method of focusing of a CRO? The principle of cathode ray oscilloscope is dash. The question is this. Principle of cathode ray oscilloscope or CRO is electrostatic focusing. This is also another question that can come. The principle of CRO is electrostatic focusing. Okay. So these are the two questions I just wanted to share with you guys. Please note this. This is the Lysage's pattern. Okay. So I hope that these questions were useful for your preparation. I was receiving a lot of requests to do this video because for the technical assistant examination, this electronic instrument and measurements is a subject included in the syllabus. So a lot of people was requesting for this video. I've done a part 1 of this video. This is a more advanced version of questions. There is a little bit more difficult questions I have included in this video. In the part 1, we have discussed very simple questions. In part 2, we have discussed higher end questions. Okay. So I hope that this video was useful for your preparation. If yes, please do give it a thumbs up and also share this video with maximum of friends. And please do tell them to subscribe also. And if you want more videos, you also please do subscribe to the channel. Thanks for watching and keep on watching.